Ever pondered what happens when an acid and a base mix together? It's a dance of molecules, an intriguing mix that's fundamental to the world of chemistry. Today we're diving into the details of this interaction, focusing on two key players, hydrochloric acid, or HCl, and sodium hydroxide, known as NaOH. HCl acts as our acid, breaking apart in the water to form hydrogen ions and chloride ions. On the other side we have NaOH, playing the role of the base, also dissociating in water to form sodium ions and hydroxide ions. The real stars of the show are the hydrogen and hydroxide ions. When they meet, they react to produce water, the essence of life itself. And what's the stage for this molecular dance? It's water, acting as the solvent that enables the dissociation of HCl and NaOH into their ions. The real magic unfolds when these two meet in an aqueous solution. Meet hydrochloric acid, our key player number one. This compound, often abbreviated as HCl, plays a vital role in the world of chemistry, particularly in the neutralization reactions we're focusing on today. When HCl finds itself in water, it doesn't stay as it is. Instead, it dissociates or breaks down into two separate ions. The first of these is the hydrogen ion, represented as H+. This positively charged particle is a crucial actor in our upcoming chemical drama. The other ion formed is the chloride ion, or Cl. While it may not take center stage in our neutralization reaction, it's still a key part of the overall process. This negatively charged ion balances the charge of the hydrogen ion, ensuring the solution remains electrically neutral. So we've introduced our first star, hydrochloric acid, and seen it transform into its component parts. We're now set with our hydrogen ions at the ready. So we have our hydrogen ions ready. But what's next? Enter sodium hydroxide, the second star of our chemical drama. Just like hydrochloric acid, sodium hydroxide also loves to dissociate in water. But instead of hydrogen ions, it forms sodium ions, represented as Na+, and hydroxide ions, represented as OH. Now, these hydroxide ions are pretty important. They're like the other half of a dynamic duo, ready to react with the hydrogen ions we talked about in our last scene. Picture it this way. The hydrogen ions are like dancers waiting for their partners to arrive on the dance floor, and the hydroxide ions? They're the partners, ready to join in the dance, leading to a beautiful performance, the neutralization reaction. But let's not get ahead of ourselves. The dance hasn't started yet. For now, just remember that sodium hydroxide's job is to provide these hydroxide ions. With our hydroxide ions in place, we are all set for the reaction. Now, watch the fascinating dance of ions in action. As the acid and base coexist in the water, a mesmerizing ballet of particles unfolds. Hydrochloric acid, our acid component, parts ways with its hydrogen ions, letting them free to engage in the dance. Sodium hydroxide, our base, reciprocates by releasing its hydroxide ions. These ions, now free to react, find each other in the watery stage and form a bond, creating the life-sustaining molecule we know as water. This beautiful union of hydrogen and hydroxide ions is the heart of a neutralization reaction, where acid and base properties are balanced, resulting in the creation of water and sodium chloride. But let's not forget the silent facilitator of this dance. Water, it's not just a bystander, but an active participant, enabling the initial dissociation of our acid and base into their respective ions. It's the stage that allows the dance to take place. And interestingly, it's also the final applause, the product of the reaction. Now let's take a step back and admire the grand scheme of this reaction. The acid influences the base, contributing essential hydrogen ions. The base, in turn, influences the formation of water, offering up its hydroxide ions. And water, the product and facilitator, influences both the acid and base by enabling their dissociation and interaction. This intricate and interdependent dance of ions is a testament to the beautiful complexity of chemistry. Each participant, each ion, plays a crucial role in the progression of the reaction, leading to the formation of water and sodium chloride. And as a grand finale, the reaction is exothermic, releasing heat as the ions combine to form water molecules. And so, the dance concludes, the acid and base properties neutralized, leaving us with a solution of water and sodium chloride. But the magic of chemistry doesn't end here. This is just one example of the countless reactions happening around us and inside us every moment. And voila, we have our neutral solution. But what has really happened here, you may ask? Let's revisit the dance of the ions. Hydrochloric acid and sodium hydroxide, two seemingly incompatible substances, find balance in a solution of water. As they dissolve, they dissociate into their ions, setting the stage for the neutralization reaction. The acid, hydrochloric acid, parts ways with its hydrogen ions, while the base, sodium hydroxide, releases its hydroxide ions. These ions are free to interact, and when they do, they form water, the very medium that facilitated their release. This is the essence of a neutralization reaction, where an acid and a base balance each other out to form water and a salt, in this case, sodium chloride. But it's not just about the reactants and the products, it's about the relationships, the connections, the influence they exert on each other. Hydrochloric acid influences sodium hydroxide by providing the hydrogen ions. Sodium hydroxide, in turn, influences the formation of water by contributing the hydroxide ions. And water, ever the mediator, influences both by acting as the solvent that allows the dissociation of the acid and base into their respective ions. It's a cycle, a loop of influence and interaction, reflecting the interdependent nature of this reaction. This dance of ions is not just a random series of events, it's a double displacement reaction, a swapping of partners, if you will. The cations and anions of the reactants exchange to form new products, and in the process they release energy, making this reaction exothermic. So, what we have here is a beautiful example of acid-base chemistry. It's a showcase of the critical role water plays in facilitating chemical reactions, and it's a demonstration of the heat-releasing or exothermic nature of these reactions. So, the next time you think about acids and bases, remember this intriguing dance of ions and the tranquil harmony they create.